tal? Buen día. Soy Julián Toro, director del Congreso CITI AEC 2018. Tengan una cordial bienvenida y agradecemos su presencia, y a los chicos que están allá afuera que llegaron tarde y entonces pues, empezamos tarde. Voy a hacer una pequeña introducción de un par de minutos del tema del Congreso, las expectativas que tenemos y algo de la motivación que tenemos para estar aquí presentes el día de hoy. Hace unos años, con un grupo de amigos que empezaron una iniciativa aquí en Ciudad de México, BIMEX, se empezaron a hacer mesas de trabajo y a hacer foros de hablar un poquito de BIM en su momento. La idea fue evolucionando, algunos siguieron participando de la idea y surgió esta iniciativa de generar un congreso de tecnología e innovación aplicado a la industria de la construcción. ¿Por qué le colocamos el nombre Iberoamericano y no el nombre de Congreso Mexicano? Pues varios motivos. Uno es, yo soy colombiano y hacía parte del equipo, y habían otros que no eran mexicanos, entonces pues, oye, hay que cruzar fronteras. Lo otro es, vivimos en un mundo globalizado, por lo tanto, pues había que intentar hacer que esto fuera grande, y hoy hay varios extranjeros, varias personas que nos acompañan de varias ciudades de Latinoamérica, acompañándonos, lo cual creo que fue una acertada decisión el volver el Congreso un Congreso iberoamericano y no solamente un Congreso local. Básicamente el Congreso va a tocar 9 pilares. Vamos a hablar de Construcción 4.0, vamos a hablar de BIM BDC, vamos a hablar de Lean Construction, vamos a hablar de LEED, vamos a hablar de Facility Management, vamos a hablar de realidad virtual, aumentada y mixta, y vamos a hablar un poquito de captura de la realidad. Entonces, la idea es empezar, vamos a intentar recuperar el tiempo poco a poco. Creo que los breaks de media hora los iremos acortando para recuperar esta media hora de retraso en el arranque, mientras va llegando los chicos. Y me voy a dar el lujo de presentar al arquitecto Patrick Macleamy, nuestro primer conferencista con la primer charla magistral. Tuve la oportunidad de escucharlo hace un par de meses en Barcelona. Y aunque tengo aquí el currículum, preferiría hablar un poco de Patrick, de lo que sé, y sé que ha aportado muchísimo a la causa de trabajar un BIM completamente abierto, un BIM sin fronteras, un BIM completamente colaborativo, donde han trabajado en la generación de normas y estándares internacionales para promover el buen uso de esta metodología de trabajo. Y creo que, pues aparte de decir que es arquitecto con maestría en la Universidad de Illinois, con estancia académica en Italia, comprometido con establecer estándares de calidad, confiabilidad y eficiencia en la industria de la construcción y la infraestructura, ayudó a cambiar la naturaleza de la industria con un sistema verticalmente integrado y altamente eficiente que emula la fabricación. Cuenta con más de 50 años de experiencia y creo que muchos de ustedes, pues, lo conocen, han oído hablar de él y creo que no necesita más presentación que él mismo. Patrick, welcome.
Thank you. Thank you. Good morning, everyone. Buenos días. ¿Cómo está? Okay. Go forward, go backward. I got it. I'm very happy to be here today, not in my capacity as an architect so much, although I'm very proud of being an architect, but here representing BuildingSMART and what I think is our digital way forward for buildings and infrastructure. But I think I'm easily the oldest person in this room. If there's someone older than me here, please stand up if you can. And I want to talk about my journey a little bit and then come into where my journey brought me and why I'm here today. It is time for us to change. I've been saying this for at least 20 years. It's still true. We're changing, but in my opinion, we need to move faster. I was because I'm the oldest one in the room, I was trained in a traditional way. Drawings on paper. I used pencil, not ink. I'm not that old. These were the tools that I used. Some of you younger people may not know what all of them are, but they were all an essential part of my tool set. No computers. And my two favorite tools were these. I had some young people ask me, most people know that it's an eraser at the top, but a lot of people don't know what that thing is on the bottom. But it's an electric eraser. And I found myself using an electric eraser more than anything else. My drawing was okay, but I kept making mistakes or learning something new, and I had to erase my drawing. Now that's all behind us with the computer, but this is the way I learned. And the difficulty we have with traditional work is that we're describing something in 3 dimensions with 2-dimensional drawings. So if I design a house for my dog, which I did, it's pretty simple, and 2D drawings work okay. There's no mechanical system here, there's no electrical, there's not too much structural, a few nails and some glue. So it works pretty well for simple buildings like this. But then after graduating from university, I went to work for HOK, and there the projects were not simple. They were complicated and big, and they became larger over the years that I worked there, 50 years. Just an example of a few of these buildings. I'm not selling HOK today. That's not my job. But these don't work well if you have to describe them with drawings in 2 dimensions. And try to imagine the 3rd dimension. They're very nice, pretty buildings. Fortunately, they work well. But each one of these projects had difficulty because we couldn't describe things well enough to communicate to our contractor. This is the original Apple headquarters. Of course, there's a new one that's a big circle. And my own opinion as an architect is, it looks great from an airplane, and on the ground it's very boring. But I'm not Steve Jobs, and so he can do what he wanted. So after about 10 years of working at HOK, I began to understand things better and know that we had to change. We have to get better at what we do. And this was our database. This is how we kept information. And it was cumbersome. Drawings are heavy. You have to find the right drawing and the right detail. It seems pretty ancient by now, but that's the way most of my career we worked. These were specifications, no hyperlinks, no way to get to the information quickly that you want, no Google Drive. We just had to find things the old way by reading. And owners loved us because we gave them a room full of owner's manuals for big buildings. Here's how you operate everything. And again, no organization, no structure to it, just paper, lots and lots of paper. Here's a great difficulty with our building industry. I like to compare buildings to manufacturing. Is it fair? Is it a fair comparison? Manufacturing, they build automobiles in factories, and they make many, many thousands of the same kind. And we do buildings kind of one-off, and each building is on a unique site. So the comparison is a bit unfair. But actually, what I would say is buildings increasingly are made from products that are manufactured. Think about this. The contractor's job is to assemble a building more than build it today. Schedule the delivery of pre-made materials to the job site, like the windows or the walls, and put them into place. So I think we're more like manufacturing than we think. But look at our shortcoming, especially the two in red. Buildings consume, a lot of people don't know this, when you think about energy conservation, not using so much energy, buildings consume more than all the cars, trucks, airplanes, boats on the planet. Buildings are always on. Cars and boats and trains are not always on. That's one of the reasons. Buildings are always turned on. They're always heating or cooling or lighting or something. So we have a big job to do to get better, those who are in the building industry. And buildings are also, because we have so much waste in the design and the construction process, we fill up landfills. 40% of our landfills are solid waste from construction process. That's a lot. And when are we going to improve our efficiency? Here's a little chart. Shows the growth of efficiency in manufacturing versus construction. We are going the wrong way. We are going the wrong way. Why? What's wrong? Why can't we seem to get better? This includes the era in which we all now use computers and good software programs. You'll hear from software companies later today. Why is our efficiency still going down instead of up? Yes? I'm being told to do something. Step back for the light. Is that better? Is it okay? We bien? Okay. Okay. I thought she didn't want me to fall off the front. Okay, so let's carry on. You know, you never can trust these old guys. They might fall off right off that edge. So we need to make changes. And what are they? And I think that there are three major things. If you have heard me speak before, you will have seen some of this. This is the first one. Teamwork. Manufacturers, design and construction or assembly are all in one company. In buildings, we separate design from construction, whether it's architecture, engineering, design, or construction, and we further subdivide it into subcontracts. And our typical model is this one, where the owner has to sign two contracts, one with the design team and one with the construction team to get the building built. And you notice there's no contract between the architect and the contractor. We are told in our contract with the owner, we must coordinate with each other. So we exchange information in that dotted line. And that doesn't always work. We sometimes get to the place where we don't trust each other. We begin to practice in defensive ways. And that opens up a risk gap. That's where the risk is. We're not coordinating fully because we don't want to reveal our weakness to the other. And so that risk gap is a partial vacuum, and nature always fills a vacuum with something. Now, what is it filled with in our industry? Those guys. They don't build anything. They don't design anything. They just take money. They just take money. Do you understand that? They don't design or build anything. Their job is to try to help us coordinate better, but we're still working within that flawed contract system. So this doesn't work so well. Over the last number of years, we've started to change. At my firm, HOK, more than half of our projects now don't use this model. And I think it will soon be almost none will use this model. So let's blow up the old relationship. There's still the three players, and let's replace it with some form of integrated project delivery or other shared systems so that architects, owners, and contractors each have a place to, a role to play, and we're each responsible to the other. And the best way for this system to work is that line at the bottom there, shared reward. If we all do a good job, we should all get paid for it. That's a good incentive anytime. So that's the first principle. Okay, now this thing. I did not name this the Macleamy curve. I did not do that. I called it the effort curve because it's a measurement of effort over time. And it got picked up by so many other people and used in their presentations, which is fine, that they started referring to it as the Macleamy curve. So I finally gave up. So this is the Macleamy curve. And what this curve says, and how many of you have seen this? A bunch of you. Okay. Some have not. That's good. All right. This looks like a diagram of a snake that swallowed an elephant because there's a big bulge in it. Typical way to design a building is to start on the left with a small team and go through programming and schematic design. And after schematic design is approved, schematic design is pretty sketchy, not too much information. Then we start to grow the team, and we go into design development, and then the peak of effort, that top of that bulge, occurs in the construction documentation phase of the project, where we prepare documents for the contractor. It used to be paper, and now it's models. But it's the same process. And then after bidding, then the design team has a small effort over the life of construction. That's that long tail on the right. But what's wrong with this? Well, there are two things wrong. The first is that our ability to control the cost of the project starts at almost infinity at the beginning. And as we go further and further along, our ability to control the cost flatlines. It becomes zero. There's no way to control the cost at the end of the job. You can maybe control the cost after bidding. If the bids are too high, you know how architects do that? They substitute cheaper finishes. That's a failure. That means the building is not going to be a good building. That's the only other way I know, once all the decisions are made, to control the cost, is to cheapen the building in some way. The other thing that's wrong is that the cost to change things starts at zero, very simple at the beginning to make big changes to that building. But as we go further along, the cost of change becomes very expensive. And when we get into construction, it's very expensive indeed. So where those two curves meet, whoops, I pushed the wrong button. That circle, point of no return. If we have not solved the building, the program, the detailing, the coordination of all the systems, by that time, we will have a problem project. We'll have problems during construction. We may have a litigation phase at the end. Nobody wins when we do this. It's all very difficult and expensive. So what can we do? Well, now with computers and really good testing software that can test early design concepts for compliance with the program, cost, effective energy conservation, and so on, we can actually organize this curve differently by shifting it forward. Come on. There it goes. The green one. We need to spend more time early getting things right with software and with collaboration between the design team and the construction team. You see how far in advance of that circle that green curve is. That shifting of effort forward in time so that things are really right and the contractor and the architect and the owner are all in synchronized about the solution. That's a better way to design and build. Okay, here's what you all, probably many of you have seen this. It's okay, you can see it again. This has to do with not effort over time, benefit over time. I'm an architect. I naturally think about the beginning of the work because that's when the architect is hired. But in fact, the payoff is at the end. For every dollar or peso or euro or Japanese yen, whatever, that we spend designing the building, we spend about $20 assembling the building. That's the work of the contractor. I'm calling it deliberately assembly, not construction. And after the building is finished, over a natural life of a building, 30 to 50 years, and this varies dramatically depending on the kind of building, to operate that building, to take care of it, to make repairs, to clean it, and so on, costs about $60. So 1, 20, 60. The real money is at the end. So what? Typically, owners think about the first two parts in one piece. I want a building, so I'm going to hire an architect and a contractor, so I'm going to get the building designed and assembled. And the next piece is another part of the budget. It's not a capital budget, it's an annual operating budget to price out the expense of operating my building. But the big payoff is at the end. We all know what BIM is, building information modeling, and the data that we generate in developing a good model for the contractor to follow. It's a model that's enriched with data about everything that goes into that building, how it performs, how you take care of it, and so on. All that paper stuff that I showed you earlier should be embedded in this model. And if we do a good job with BIM, we should be able to save 10 to 20% of that dollar and return that to the owner, or maybe share it with the owner as a shared benefit of doing a good job. Now the next piece, BAM, building assembly model. Remember, contractors are not assembling buildings, they're not building buildings, rather, they're assembling buildings. So now you have the contractors dealing with 20 times as much money as the architect and assembling that building. If the contractor has a good model from the design and uses good modeling software to schedule and price and procure the materials and so on for that project, in my estimation, a good contractor can save 10 to 20% of that cost. Think about that. You save 10%, that's $2. You paid for your architect, and you still have a savings. You save $20, you can return $20 to the owner, $4, and you can share $4 in savings with the owner, or maybe the owner keeps it. Now the big payoff. Boom. I'll tell you a little story. What does BOOM mean? Building Operation Optimization Model. It actually would have been better maybe for me to call it a BOM, Building Operating Model, BOM. But I'm told that if you say that in a theater like this, it's against the law, because people might panic. There's a bomb in the room, so they would exit. So we're calling it BOOM instead. So BOOM is pretty cool. Bim, bam, boom. Here's the thing about BOOM. A good owner with the right information from the architect and the contractor, the BIM and the BAM modeling, can then use that information to operate a more efficient building and can save, I believe, 20 to 30% of that $60. He can just about pay for the building. It's like getting the building for free. If he works with the team of the architect and the contractor early on to design a very efficient building that can be operated for less cost. That's the piece that we're missing in all of this discussion of the benefit to the owner downstream after the owner has taken over the building is the big payoff. Okay, everybody still there? Years ago, now 25 years ago, a group of 12 companies came together. We were all U.S. based, but we were all international companies. And we said, this is, the way we're working is terrible, let's find a better way. And we started this organization that was now called BuildingSMART. What was our mission? What did we want to do? Well, we wanted to make digital standards for interoperability. I didn't know what that word meant when we started. But basically it means my software really talks and is good friends with your software. That's basically what it means. But it was more than that. It was digital standards to allow designers and builders and operators to actually be more efficient in the way they design, build, and operate. So we began 25 years ago. The number of people that we had, you could probably fit us all in those chairs. Just a small group of people, very dedicated, and I've stuck with it all these years. It's my privilege to be the chairman of BuildingSMART International. Our job is to link the 4 key processes: design, procure, assemble, operate. You could say procure and assemble. That's the contractor's job. That's construction. And operate is the big payoff. We want all of those to be linked, so we have an interlinked chain. Very pretty diagram, pretty logo. BuildingSMART is open. We're open to all. We're neutral. We don't favor one software over another, and we're not for profit. We're chartered in the United Kingdom, just because it's on the doorstep of Europe and most of our chapters are there, but we operate across the globe. These are our 4 goals. We want to promote open BIM standards, compliance, which means how can I measure if I'm actually meeting the open BIM standard that you've set forth. So we've now started a compliance regimen, much like LEED has in the United States for energy consumption in buildings and so on. And we're now certifying, we've certified software for years as being compliant with our IFC releases. We're now beginning to certify individuals as certified in the BuildingSMART arena, and eventually we're going to certify models themselves, the BIM models, so that if you are an owner and you want to invest a little more money, you can achieve a certified model. We promote adoption of open BIM standards, and of course we promote use. That's why I'm standing up here. I want you all to adopt and use open standards, which I believe is the way forward. With all good deference to Autodesk and Bentley and Graphisoft and others that are here, Trimble. You're all good companies. You all do wonderful things, and we want you to prosper. But we think that all the other people out there that are your customers need to choose the software that works for them, and it needs to work well interchangeably with whatever other software they use or their team members use. So that's why we're open and neutral. This is our chapter list. We started in the US with one chapter, and I can remember some pretty exciting times going to Europe and Asia, promoting chapters, and now we have about 20 chapters, and we have 2 more chapters that are going to be in front of our board of directors next week when I return. It's Turkey, and another one that I won't tell you. Be a surprise. So we've spread across the world, is the point. The only way for standards to be adopted is if they're adopted globally. So BuildingSMART has now become an international organization with roots in many different countries and many different continents. How do we operate? The chapters own BuildingSMART. They form an international council which meets once a year, and the international council elects a board who hires a management executive and a small team. We're advised by a strategic advisory council. That's a group of donors that have put serious money into BuildingSMART's operations. And we operate 3 core programs, which I'll talk about next. We have a user program, a standards program, and a compliance program. That's what we do. The user program is industry outreach and identification of problems. Where could a new digital standard help somebody in the building industry, or more increasingly now in the infrastructure industry, which is our cousins? And then in standards, the middle section, we actually work together to create digital standards, and if they're appropriate, then we pass them on to ISO for adoption by ISO and member countries. And compliance at the end, there's no sense having a standard if you can't measure compliance with that standard. So we have a growing compliance operation as well. Each one of these sections has groups of people that operate. We have an international user group, and we have groups in various chapters that identify problems. We also have groups of companies or entities like airport operators that have banded together and said, you know what, we need digital standards for our industry. The rail operators, the biggest single project we have now is helping rail operators in Europe and Asia develop common digital standards. We have a new section of 3 at the bottom: construction, rail, and airports. Those are new standards rooms where standards are being developed. And then finally, in the compliance area, we already have a program in place to test compliance with software. And people is just now being issued, and pending is processes and the data models themselves to find ways to actually work out a compliance regimen for those. That's who BuildingSMART is, but this is really who we are. This was our BuildingSMART Standards Summit that was held in Tokyo, Japan in October, and we had just almost 500 people there. Fantastic group. People from all over the world. The thing that makes me the most proud is that people from different countries are working together to solve common problems and developing great friendships along the way. My personal name for IFC, which is the best-known BuildingSMART product, is International Friendship Club. That's who we are. That's what we do. We need new chapters. We have no chapter in south of the U.S. border. The U.S. and Canada both have chapters. There is no chapter in Mexico and none at all in Central or South America. We're open for business. If people here in Mexico or elsewhere in South America are interested in forming a chapter and want to understand how to do that, I'm here all week and available to speak with anyone and hope that you join with us. This is your opportunity to join with this international community and become part of it. That was an advertisement. Thank you very much. Muchas gracias. Thank you.